Hello, mathematicians. Today we have two tasks. First, we're going to do a problem string that focuses on efficient multiplication strategies. And then we're going to work on volume with doing some more work with Brad's baseballs. So over here with my problem string, you can see that my first problem is 4 times 3. And I know I can represent multiplication with an array, just like this. But 4 times 3, I know that that's 12. That's just one of my facts that I have. And then I'm looking at this next problem, which is 4 times 6. And again, I know I can use an array to help me with that. And one of the things that I'm noticing is if you took this array and moved it down, it doubled. I'm wondering why it doubled. I'm noticing my 4 stayed the same. So this factor side is still 4 in both of these. I'm noticing that this factor doubled. So instead of just 3 across, it is now 6. So what did that end up doing to my area? Well, now it's 24. You are going to think through that pattern by continuing to solve 8 times 6, 4 times 12, 2 times 24, and 1 times 48. And you will do that to complete the problem string. Now let's talk about our work with Brad's baseballs. So I just wanted to review with you that a dimension is length, width, or height of the figure. And when I'm talking volume, I'm talking about all three of those. If I just wanted to know the area of that base, remember that is just width times length. A rectangular prism is the only 3D figure that we've been practicing finding the volume of. And that's important to note because cylinders and other 3D figures, we don't find the volume in the same way. So a rectangular prism is any 3D shape who has 6 faces. So all of its sides and its base and its top are all rectangles. And a square is a rectangle. So you might have noticed this one's a square. That is why. So let's review what we already know about Brad's baseballs. So as I was looking through your forms, we found every single combination. So I really want to focus on the height. So let's first talk about the 3 that were one layer. There was a 1 by 12 by one layer. There was a 2 by 6, one layer. And there was a 3 by 4, one layer. Then I moved it to 2 layer, and we have 2 combinations that were 2 layers, a 2 by 3 by 2. And if I take this one and stack it, it's another 2 layer, a 1 by 6 by 2. Then we had a couple that were even 3 layers. So for those ones, I had a 2 by 2 by 3. And I had a 1 by 4 by 3. And then I had a 6-layer one, which was this one. And it was a 1 by 2 by 6. Then I had that really tall one, a 12-layer. So it was a 1 by 1 by 12. I also took a look at your forms, and I noticed these 2. So that's this one here. And you'll notice that we started with it like this in the first picture, and then we flipped it up like this for the second picture. And I asked you if those were the same 2 boxes. 44.4% of you thought they were the same and should count as one rectangular box, and many of you said that was because they had the same number of cubes. 55.6% of you thought they were different and should count as 2 rectangular boxes because the bases were different amounts. For our assignment, you are going to assume that anytime the base changes, it is a different box. Because really all of these have the same number of cubes. They have 12. So your job, and your teacher is going to explain this a little bit, you are going to get a group that you are going to be assigned a layer for. And now instead of 12 boxes and baseballs, you're going to be testing for 24. How many combinations can I make? You're going to figure that out with your group today.